Hello and welcome back to AP Precalculus, one a day to get a 5 in May. This is the 5th episode, and today I'm going to be doing a problem from Barron's AP Precalculus Review Guide book, and this is a problem from Unit 2 with logarithms. So before I go ahead and tackle this, just give it a try on your own, and you can see how you did, I guess. Alright. So hopefully you paused the video and did it. But this is a cool problem because it's going to require a couple different formulas. So we have is log base 2 of x plus 1 is greater than log base 4 of x squared. Okay. So notice that we have a log base 2 and a log base 4. What I want to do is I want to change this log base 2 into a log base 4, right? So how we're going to do that is, well, we're going to use the change of base formula, okay? Which is log base A of B is equal to log base C of B over log base C of A, right? Where B is going to be a thing you're taking the logarithm of, and A is that base, right? Okay. And what we're going to let C be is C is going to be 4, because we want to change this 2 to a 4, right? So what we're going to get is if we change this into log base 4, we have log base 4 of x plus 1 over log base 4 of 2 is greater than log base 4 of x squared. Alright? So, log base 4 of 2, this 2 is the same thing as, let me think. Wait. So, wait. Yeah, log base 4 of 2 is going to be equal to 1/2, because 4 to the 1/2 is equal to 2, right? That makes sense. So, we can change this, because this is 1/2. What we get is 2 log base 4 of x plus 1 is greater than the log base 4 of x squared, okay? Now, notice that we're multiplying this 2 out here. What we want to do is we want to raise both sides to the power 4 to get rid of that, but before we can do that, we really want to get this 2 inside here, right? And what we can do is, since it's being multiplied, remember that log base, any log, it doesn't matter the base, I'm not going to say the base, log of A to B is equal to B log A. So here we have 2 log base 4, so we can bring, like we bring this B inside, we bring that 2 inside and square what's inside, and it will remain valid. So we have log base 4 of x plus 1 squared is greater than log base 4 of x squared, okay? Now let's raise both sides, well, let's exponentiate both sides to the base of 4, right? And those logs and those exponents, or bases, will cancel. Yeah, not exponents, but bases. And what we'll be left with is x plus 1 squared is greater than the logarithm, oops, nope, no logarithm is greater than x squared. Okay, now I'm not going to take the square root here because then you might like take square root, add plus or minus, and then you'd have two scenarios. And so since it's more than what needs to be done, because if you just expand this x plus 1 out, remember x plus 1 times x plus 1, if you expand that all out, here I'll do that, same thing as x plus 1, that's greater than x squared. If you expand that, you get x squared plus another x plus 1, so you get x squared, because then you have two x's, and you have 1 that's greater than x squared. Alright, let's subtract x squared from both sides. Notice how this is very nice. Now we don't have to worry about any x squareds. We're only going to one solution, or I guess one answer interval, whatever. So 2x plus 1 is greater than 0. Alright, and this means if you subtract the 1 from both sides and divide by 2, you get x is greater than negative 1/2. That is our solution that we get. So let's test. And then after we test, we're going to look at our original equation, see if there's anything else that we might have to restrict. So let's test for a number that is greater than negative 1/2. So maybe negative 1/4, I guess. So log base 2 of negative 1/4 plus 1. We don't know, so we're gonna put that question mark. Log base 4 of negative 1/4 squared. This is gonna be 3/4. This is going to be 1/16. I know that this is going to be, here, let me just plug this into my calculator on the left. So negative 0.415. We're asking, is that greater than the log base 4 of 1/16? So is that greater than negative 2? Yep. Let's test something that is, instead of it being greater than, it's less than. So let's try negative 3/4, because if this is negative 1, if x is negative 1, we know this is going to be 0 over here, because negative 1 plus 1, and we know that's not going to work. So let's try negative 3/4, just see if that might work, since we won't get an undefined like that, but we might get something that is false. Okay, log base 4 negative 3/4 squared. So that's just going to be 1/4 right there. Alright, negative 2, we're asking, is that greater than log base 4 of, that'd just be 9/16. Negative 0.415. Nope. So, as you can see, seems like our interval works. Seems like we have a good solution. But, if we go back and check, we need inside the logarithm to be positive, right? So this is only going to be positive when we positive and not equal to 0, right? This is only going to be positive and not equal to 0 when x is greater than -1, right? Because when it is -1, it's 0. When it's greater than -1, when you add 1 to it, it's gonna become negative, right? Now this, what we need, this is always going to be positive, but it's going to be equal to 0 only at 0. So here we can't have that equal to 0, right? So that's the only restriction, right? For this one. But for this first one, x is greater than -1. Well, that's already satisfied by x is greater than -1/2, because everything greater than -1/2, take for example, like -1/4, that's going to be greater than -1 either way, right? But over here, 0 could be, according to this over here, this greater than -1/2. 0 is greater than -1/2, so it's not in our original restriction. But that's why you need to be really careful about looking at your original function and seeing, okay, even if this satisfies, even if this does work, are there any things I have to watch out for in my original equation? So our final solution is we have x x is greater than -1/2 and x is not equal to 0. Alright, that is our final solution. Any x will work as long as it satisfies that criteria. This is a bit of a longer one. I just wanted to try and fully conceptually explain it. The next video will probably be a short one. I like to vary lengths, but thank you for watching the video, and I hope that you have a great day.